Okay, can you still see the slides? Yeah. Okay. So finger crossed. Okay. So let's dive straight into it. So before we go through the first notion that we need to define is this notion of a binary operation on a set. So you know what a set is. This is one of the prerequisites that you need to know. Most of you already know what a set is. So a binary, in an informal manner, a binary operation is just a rule. It's a rule that you impose on set X. Set S. That takes two elements. Any two elements of set S. Let's call them A, B, and then it generates another element. A star B. Okay, that's it. So it's a rule. I give you a rule to say, here's a set. Here's this rule of taking two elements of the set S, and then you generate a third element in S. Okay, so if you want it to be more formal, it's actually a map. Okay, it's a map from the Cartesian product of S. Okay, to S. Okay, so essentially this thing of A star B is just an abbreviation for the actual map star of the pair AB. Okay, so mathematicians would say this is just an abuse of notation, rather useful abuse of notation, because it's much easier to handle this to work with this than to work with this. Okay, so another thing I want to comment is that it's possible to equip the set S with more than one binary operation. Okay, so this is indeed what enables one to go through other algebraic structures like rings and fields and these things. We'll come back to this at a later stages in the next module when we talk about the notions of algebras and these things. Okay, so another thing I want to introduce here now, is this notion of commutativity. So the binary operation on S is commutative or abelian. I will be using this term, but they are synonymous to each other. They mean the same thing. Sometimes I will use commutative, sometimes I will use abelian. So the binary operation is abelian if you have this condition. So if A star B is the same as B star A for any two elements A, B in the set S. If that's not the case, if for some A, B in the set S, we have this, then we say this the binary operation is non-commutative or non-abelian. Okay, so it means the same thing, just like commutativity and commutative and abelian means the same thing. This is also the same thing. Okay. Let me check the chat. I hope I'm still with you guys. Can you see the slides? Yes. Okay. So far, so good. Okay. Okay. Good. Yeah. So let's see some examples. Okay. So suppose that S is a set of natural numbers N, and let's the star be the ordinary addition of natural numbers. Okay. Let's see the poll. So the claim is it defines a binary operation in naturals, right? Yes, in the chat. Yes. Okay, so this is true. I hope nobody disagree. Is there anyone who doesn't see why the plus, the ordinary addition on natural numbers, is indeed a binary operation on the naturals? Nobody disagrees, right? Yes, David actually made a very interesting comment. Whether n, the naturals, include 0. If you are if you follow the piano arithmetic, yes, 0 is a natural number. The successor of 0 is a natural number, and so on. I will actually leave it to I will leave it to you actually to decide. Okay. Now, the second example. Now consider S to be the set of all odd natural numbers, and let's the star operation be the ordinary multiplication of natural numbers. So the question is whether the multiplication on the set of odd numbers is a binary operation on yeah. Yes. Okay. Excellent. So I see a very interesting comment here. George is saying n plus without a 0. Yeah. Yeah. Okay. Have I made any typo? No. Obviously, I could have used the Z, and then but yeah, let's. I'm just giving some example. What about this one? Consider again S to be a set of odd numbers. What now if the binary operation is not the multiplication, but instead the binary operation is the addition? No. Okay, so it fails, right? Okay, so far so good. Excellent. What about this one? Now, consider A to be a non-empty set, okay, just to make things simple. And let S be the set of all bijective maps from A to itself, okay? And suppose that the star is now the ordinary composition of maps that, we learn in high school, okay? So the question is if the composition defines a binary operation on the maps. And if yes, is it abelian or non-abelian? Yeah, I am back while you guys are on the chat. I think it's better we just try to continue. The thing, it won't take long anyway. Yeah. So what's the verdict? Yes or no? Yeah, okay. I will let you retain, for those who are not sure in these things, I will let you continue even the discussion in Discord and these things, just so you can have some unanimous thing amongst yourselves, whether the thing, yeah. Amir, you made a good interesting point also. Yeah. What about this one? The set I've chosen to the set of complex matrices, because especially you guys are coming from quantum computing. Most of you, you deal a lot with complex matrices, right? So now let's this be the set of n by n matrices. If this is too general, you can just use a toy example, 2 by 2 matrices, for instance. Okay. The question is whether the star being the ordinary matrix multiplication is a binary operation on a thing, on the set of n by n complex matrices, right? Yeah. So This is definitely okay. Yeah. And George made a very interesting point. It depends on the n, right? If n, yeah, if n is equals to 1, then obviously, yeah, for n greater than equals to greater than or equals to 2, then yeah, Amir, you have a point. Yes, so that's good. This one, so in group theory section, this we will come back to this again in a much more. This is just a little bit. We are just a little bit sloppy here on the thing, but let's denote this thing that I call GLN of C be the set of all invertible n by n complex matrices. Okay, so if you are again having problems with this being too general, you can just imagine 2 by 2, just as a toy example, 2 by 2 matrices that are invertible. Okay, now consider the star to be again the ordinary matrix multiplication. So the question is whether this also defines a binary operation on this set, and is it abelian or no abelian? No abelian, okay. What about the addition? But think about, first of all, does the addition, the operation of addition defines a binary operation in this? In other words, if we have two invertible matrices, if you add them together, is the result necessarily invertible? In addition, huh? Remember, in this is not this guy, this is this guy here. This is the set of all invertible matrices. Okay, so if you say that the addition is a binary operation on this means that when you have two invertible matrices, if you add them together, the result is another invertible matrix. Is this the case? Does anyone agree with George? For the product is simple, right? The thing, you know. Okay, this is another thing, because this is really part of this thing that I will leave you. I won't answer immediately. I will leave this for you to go and scratch your head, but go around and discuss amongst yourselves. And it doesn't have to be just C. You can think about any other. This could be the reals, for example. The set of the reals, or even the integers and these things. Okay. So David. Okay, I am back, and I see very interesting conversation going on in the chat. I think we should just carry on, even though the thing, now that you are actually engaged on the chat. Okay. Not many things, yeah. And not many slides left anyway. So, even though we are having technical difficulty, this will be very annoying for those of you who are watching on the YouTube later. But for those of you now, I think it's just better if we carry on. Yeah, do you agree? Yeah. Okay, so it seems like perhaps I was misunderstanding the last question of I will come back to your question, the thing. Once I go through the slides, I will bring George in to see if I missed anything. Yeah. So yeah, so it seems like you're still on the conversation about the binary operations on the thing on matrices. I'll come back to that. Okay. So where was I? Yeah. So this condition here. So this condition here is called associativity. So we say the operation, the binary operation, is an associative operation. Okay. As a side note, there is also, if in some certain circumstances, especially in ring theory, there are the flexibilities. Mathematicians sometimes don't require associativity. This is something that we might come back to in another in a technical module 2 and these things, when we talk about rings, non-associative rings and these things. But for our purposes, first of all, we are dealing with one binary operation, and it's associative. Okay. Another thing, just like in the topology section, we always have like a pair where we have the underlying set, and then we have the topology and these things. In here also we'll have the underlying set, and then in this case we have the binary operation. So, but whenever the binary operation is understood, there is no need to be writing this pair and these things. We just say S and then call it a semigroup. Okay. But for us, in the general, in the abstract, we will just keep using this until we actually get to concrete structures and these things. So for the time being, we'll be using just this this notation. I mean, both of them will not omit the binary operation because we're not dealing with. There's no binary operation that's fixed for us in order to omit. Okay, so. As you can guess, a semigroup is abelian or non-abelian, depending on whether the binary operation is abelian or non-abelian, right? Another definition I would like to go through is this notion of a sub-semigroup. So it's giving a subset of the underlying set, okay, that's generating the semigroup structure together with the binary operation. If that subset is also a semigroup under the same binary operation, then we say it's a sub-semigroup. Okay, and obviously this is trivial that it's this is a semigroup of itself. Okay. I'm not sure how do you pronounce it. If it's semi or semigroups. So it means the same thing. Okay, I might be pronouncing it wrong. Okay. Yeah. So it's all about the thing. This is it. You have a binary operation. Okay. Now I see a comment on the chat about closure stuff. I could have started much more abstract, in defining a binary operation to not necessarily be like, to be a little bit more abstract, where it does not cover all the elements of S. And then we say that the binary operation is closed if it covers the entire any pair of elements. But I decided to start this way because this is a modern way of doing it, of exposing it. Okay, so now let's see some examples again. Okay, so I know you're still debating. So using the same previous example, the question is whether, again, if we have S to be the set of all bijections from A to A, whether under the composition this is a semigroup, and as a consequence, whether it's also abelian or non-abelian as a follow-up, I mean, okay? And the same with the matrices. Again, similar question, okay? I'll leave this to you to debate on the thing, because I know we are running, given the disruption and these things. I'll just go through this like a challenge that I have for you. So suppose that S star is a semigroup, and let's define this set S prime to be the set of all the elements of S that commute with all the elements of X. There's I missed something here, but you get the picture. You know, I should have said for all X in anything in S. Okay, so the question is if this is a sub-semigroup of S. Okay, so this is a challenge. You don't have to answer it now. This is a challenge for you to go and think about it. And another challenge I have is that consider like two semigroups. So S1 together with a binary operation that I labeled *1, and the second semigroup S2 with another binary operation. Let's say I labeled it in this case *2. Can you construct a semigroup structure on the Cartesian product of these of the underlying sets? Okay, you know what a Cartesian product is. This is set theory 101. And also, can you generalize your construction to say, you know, we have n number of semigroups, you know? Okay, so that's one challenge. And another trickier one is consider, this is just consider, for example, if S1, the first semigroup, is abelian, but the second one is non-abelian. The question is if the Cartesian product of, you know, whichever the construction that you came up with, whether that's abelian or non-abelian. Okay, this is a challenge for you. And another challenge I have is identify at least a non-trivial. By that I mean that it's not let's say it's not the actual semigroup itself, but some a proper subset of the set that's of the construction with an underlying semigroup structure. Okay, and then you have this challenge. This is very important for those of you who are interested in cryptography, for example. You will see these guys a lot, you know. So I challenge you to try to identify a semigroup structure of this, you know. To give you a hint, you know, I will give you a hint, you know, mod n arithmetic, for instance. Okay. Okay, so this is a challenge for you. As you can see, we started very simple. You know, I'm really sorry for the technical stuff on the network side. I'm pretty sure it's. I mean, not sure. One can never be sure. It's probably not just my network. It's more probably also to do with Crowdcast, I think. So that's it. We can have. I mean, you can go to GitHub. I will upload these slides and these things. You probably, you know, because of the disruption, you know, you need to go through the slides more than, you know, you have listened to me and these things. Okay. Okay. Let me pull George just in case, George, I missed something on the chat because of all the. I see some interesting conversations going on. That's good. I'm really sorry for the thing. Okay, so David's saying, I need to be sure semigroup, not clear why semigroup is not just a group. Well, we will come to that on this to do with, there's one question that I think one point that Stefano made about removing some axioms, relaxing some axioms from group theory. Yes. So in fact, just to give you a hint, let me go back to the thing. Yeah. As you can see here, obviously a group is a special type of semigroup. A semigroup doesn't need to be a group, okay? Because we are only imposing, the only condition that we are requiring is the associativity, okay? George, I cannot, yeah. Okay, so
I'm just testing my sound, and I want to be sure I got rid of the echo for everybody.
Yeah. So to go to the thing, here's the condition for a semi-group. In a group you have the. Let's see what's missing here for this to be a group. What we need to add. We need to add the identity. We need to add the invertibility condition and these things. But in here we are not. We are just assuming the associativity. That's all we are assuming. We're not assuming that there exists an identity. There exists for each element there is an invertible element. We're not insisting on that. Okay. Which is why you see this. Let me go back again to the slide. Obviously, a group is a semi-group. In fact, we'll in the next session we'll define the notion of monoid, and this is where the identity and these things start showing up. Okay. So yeah. So David saying, yeah, you got it. Yeah, no identity. Yes, no identity, and also no invertibility. There is no requirement for invertibility, right? Because in this condition, let's see, is it? Yeah. So all we are requiring is that it's associative, the operation. Okay, nothing else. Yeah. So yeah, thank you, George. Now, I didn't actually. I'm not keen into recommending yet a test book until we get to the group section, because at the end of the day, we are just going to skim through this thing here. These guys, just to build up your abstraction, to see how things are intertwined, how you start from very basics and then you can just add structure on top, add more conditions or something, relax. And it's very funny that, not funny, very interesting that the group notion came actually before the thing, so this is like, I forgot actually, there's a joke, there's a joke somewhere, a mathematician saying that, I'll find it next time about it's very, very interesting joke about relaxing. I don't remember it quite the thing, but it's a very interesting joke. So anyway, going back to the thing, we'll just skim. The reason I'm not recommending you, you can Google and dive deeper into. We'll just skimming through these guys just before we get this. This is just like a build up. It's like we are in sports, doing preseason and these things, because I know some of you probably. I won't say, even myself, I'm a bit roasty, as you say, or rusty. So it's like a preseason in sports, right? You start building up slowly, and then you become a little bit. So that was the intention, especially for those of you who are new to this type of stuff. I thought by doing this way, instead of immediately jumping into groups, will help you. And some of the notions that we will define here will carry over to groups. So it makes it easier, for at least from my point of view, than defining all those notions in the group section, if you know what I mean. George, do you have any comment? Apart from the terrible technical difficulties that we had. I'm sorry for that.
Any comments I have would actually be out of scope of this intro course, but I will post to something on the advanced chat.
Yeah. By the way, these guys, like semigroups, for example, might seem like very boring stuff. They actually have very useful applications and these things in other things, for example, in operator theory and these things, you know. But let's not worry about that for now. Yeah.
Quickest way I can say it is that we have here a very nice tree of inclusions without overlaps. The full Venn diagram of all possibilities, associative, not invertible, not and so forth, is not a nice egg-like enclosure. It's a complicated graph.
Yeah. And obviously, in our case, because we are focused on groups and this thing in one binary operation, if we start adding more like the ring structure and these things, you know, this it can easily become a little bit more complicated in a way, especially for the newbies, you know. But the interesting stuff, just to say, the interesting stuff will really be here. But you know, what I will say is that take the opportunity to, you know, for those of you who are new to these things, you know, to have fun with these guys before we get here. I know most of the action actually will be around these guys. This is where a lot of the actual concrete applications in these where are they, in these fields that I was saying, you know, are like these guys, for example, you know, that's where or as a matter of fact here. So but take the opportunity, you know, to see how, you know, structures are layered on top of each other and these things, you know. This is that's why I decided to start you know, very simple, and then we'll keep doing, you know, more in the first section of next session. We will still be on semigroups. We'll define the notion of idempotent elements, for instance, you know, and then go through the notions of homeomorphisms. I forgot, I'm still in the topology mindset. Homomorphisms and these things, okay? These are all notions that will be carried over in the thing, over to right to the group section, okay? So that way you're already starting to be familiar with them. So that's the plan. And it was actually good that we haven't had any much coverage anyway because of the technical problems. It was actually, in the end, I think it was just better to do it. Yeah. Does anyone have any comment? Anything? I know we are running over because obviously the technical issues that we had.
Yeah. My only comment is that by drilling down to what we want to get to, which is Lie groups, we get rid of a lot of complications.
Yeah, exactly. Yeah. This is the purpose. Lie groups. You know, let me go back again. This is the thing. It's the purpose of this course as a prerequisite. So that's why, you know, we will be very narrow, just like in this section, you know, where we didn't stay much on point set topology, right? We started, you know, immediately moving towards you know, the manifold, you know, because that's what we needed, you know. So we will also be a little bit more focused. Obviously, in each of these guys, there is a lot to be done. You know, there's a lot of interesting stuff that you can do with these guys. You know, monoids and these things. You know, people. There's a lot of interesting applications in functional programming. All this stuff that you can dive into it. But for our purposes, you know, this is just. It was just an interesting way I found to get you to groups. While carrying over some of the notions that we defined without much complication. So it's easier for you. By the time we get to groups, you're already familiar with some of this stuff. Yeah.
If you know geometry, you can think of the other structures as non-Euclidean groups. You know, if you throw out some axiom or change some axiom, it's no longer a group, but it might have some interest, but really not to us right now.
Yeah. That's right. Okay. So Any other comment on the chat or something? Anything? How? By the way, I would like to feel how was it in terms of abstraction and these things? In terms of the thing, was it very easy, piece of cake, and these things?
From my point of view, it might have, but people can do this by working on the challenges. Just a little more time on the pure set theory abstraction of how you define an operation as a subset of the product of a set with itself and so on.
Yeah. Okay, so I like Stefan is saying very good. I like it like this with examples. Yeah, though I'd okay, not too abstract would have helped me to mention the the axioms of groups and semigroup explicitly. Yeah, I mean it was just it was actually intentional to the thing, and I guess with this diagram, it's like you can see it's implicit behind scenes that we are starting here because we weakened, the saying the axioms of groups. So the further you go away, the weaker the thing, the group. You throw away the group theoretic stuff, the group axioms.
Yeah, so you could sort of add a little tag to this picture where at each inner thing you're adding another axiom like inverses and unit. Or you could go the other way, have an arrow going out where you start with a group and weaken. This is a very important general concept, not just in group theory, that you can zoom in or zoom out.
Yeah. Okay. Any other thing from the chat and these things, I'm really sorry for the technical stuff. It's just the thing, until I move, I cannot connect to fix the thing, the network here for several reasons. But I think today it wasn't,
David and Stefano have positive feedback in the chat.
Okay. Yeah, so I assume it was good to carry on anyway, because we had less to cover despite the disruptions. So finger crossed that
there was some confusion about the rather tricky example of matrix addition of invertible matrices, but that can be considered a homework challenge.
Yeah, exactly. This one here, where is it? Yeah, and I really encourage you to figure it out, because this is where you can actually see that you are actually understood. You actually have the thing. So go through it and try to.
And these are all very good concrete examples. And if you work them out, then you should have a picture of what's going on with a concrete example.
Yeah. And I encourage you, I don't know, George, if you're still doing the next week. So the next session, this is actually a good time to the thing. So the next session will be on when is the thing? So not next week, the week after, on the 11th of February. We are doing 2 weeks thing. So I don't know, are you still George doing the weekly stuff on the the Friday after to do like the study thing?
I'm sorry, I didn't catch. Are we going to every other week for the lecture or not? Or are we going to weekly lectures by you?
We are sticking. We are sticking with the thing with the 2 weeks gap. Mostly because of my schedule, and it's also convenient for the newbies.
Well, in that case, once again, I volunteer because it's a very, very convenient time for me, since I've set it aside anyway.
Yeah.
But I encourage, if you have anybody in your time zone, like on the other side of the world, Japan, Australia, or wherever, to form your own little study group.
Yeah. I definitely encourage you to do that. If you are not in the same time zone as George or any other, just form your own thing. Ping people on Discord. Organize. You don't have to have the study group on Discord itself, but Discord is just a way of you organizing yourself. You can maybe use Google Meet or something. And you go through the stuff. So David is asking me. Yeah, sorry, George, go ahead.
I was thinking, especially for those who cannot attend the bi-weekly lectures because of their schedule and follow this on YouTube later and follow the slides later, it would be great for them if they can find someone else to study with whenever is good for them.
Yeah, correct. Yeah. So David is asking, we can talk about, yeah, sure. Ping. Ideally, I would like if you ping, I'm the last person to be pinged to ask. It would be nice for someone else to come in and because I encourage peer-to-peer learning amongst the community members. So I would be like the last resort to ask if no one else can answer the question. So yeah. Another question is, yes, the slides will be available on the thing, not listed because of they're always available, first of all, but not listed today because of the technical problems. Yeah, so if you go to the GitHub repository, there will be a section that I haven't created yet on the group theory crash course. I will on the thing, I will upload the slides there. Yeah.
And I also don't wish to dominate. If anybody else wants to rotate helping out, monitoring the chat during these talks, or alternate or whatever, I am quite open to that. I just volunteered to get the ball rolling.
Yeah, and one thing I want to comment at some point, I'm actually getting some grad mathematicians in some, not in the early stages, because this is like it's the thing in some of the once we get to more advanced stuff to maybe go through like in the to have some sort of tutorial with the group tutorial with some of you, especially those of you who might be maybe interested attending some external courses on things related to say quantum error correction, for instance. So this is just a hint. But this will be more in the advanced section of the thing, for it where it will help to have someone like go through like tutorial thing. I will get one of the grads mathematicians from my from the company to do that. Yeah. In the meantime, I encourage resisting you yourself to how do you say, peer-to-peer, get together and peer-to-peer learning is the best way, really. And don't feel shy or feel embarrassed of making mistakes or something, or coming up to thing. It's part of this is how you learn. So no problem with that. Okay. Any other thing that I missed? I know I don't want to hold you too much because the issues we had with the call. Obviously, this will take a little bit of editing for me to skip to the actual part of when the we started having the issues sorted. It will probably take me some time. Maybe I will try to do the uploading on YouTube as soon as possible, but the slides definitely will be available soon after. Yeah. David is asking, slide will be on GitHub near. Yeah, I will create a section called Group Theory. I will send an email also to thank the, and also on the description on YouTube, you will see the link on the to the actual URL of the thing, the slides. So yeah, okay. So if you don't have any other questions, I know the thing we can just maybe end it here. I know it's already we're already over because of the issues that we had, and I'm really sorry for that. Hopefully it won't happen next time. But at least I think it was good to continue to just go through. I know it's frustrating. Yeah, so George is saying thank you and good to be back. Well, in that case, have a good weekend, everyone, and I'll see you next time in 2 weeks' time. Okay, thank you, and sorry again for the technical, the networking stuff. Okay, George, thank you, and I'll see you next time.
Okay, I'll try to get there 5 minutes ahead next time with a working system.
Yeah, no worries. The thing is just one of these. I will also now, obviously, I've been trying this Brave, even though I made the setting a little bit more friendly to the thing. It didn't seem to work. That's why I had to revert back to Google, but then I had to do all sort of authentication stuff.
Yeah, I hope to have something rigged up with a camera and headphones, and that should solve the echo problem.
Yeah, no worries. It's not the thing. It's mostly from my end. So yeah, thank you so much for doing this anyway. So we catch up next time. Thank you. And let's get the Discord stuff alight, the chat. Okay, see you. Have a good weekend. Bye for now.